Wow, wow, wow. So I came across this bridge yesterday when I was walking on my daily walk. I've walked this park a lot of times, but this is the first or the second time I'm coming this direction, and I came across this masonry two girder bridge yesterday, and I said to myself I was going to come back early this morning, even though the time is so cold, to give you a view of this bridge. As you know that I'm a bridge person. I design bridges, I review bridge plans, that's my daily work. So I'm just giving you a view of this bridge here. So let me give you a background of this bridge. So this bridge is really a two span, a two non-continuous span masonry steel girder bridge, right? And as you notice, it is going over water. So whenever time a bridge is going over water, any waterway, it is mandatory that you do a hydrology and a hydraulic study to see the impact of the water that is going to impact the bridge. Whether the water is going over the bridge, you want to do your frequency flood, your 50-year flood, your 100-year flood, to see what is the elevation of that water. Also, you do that hydraulics and hydraulic study to determine if the bridge is cover critical, because you do not want the water to erode the foundation that can cause differential settlements and cause your bridge to collapse. So let me label some of the parts of this bridge. So it looks to me like it is a overpass bridge for a train. So here, this is abutment 1, and as you can observe, it is constructed of stone masonry. And if you look at the top there, you can see there is a concrete capping, right? A reinforced concrete capping. So the wing walls, this is also stone masonry. This is abutment 1. I don't know if this is abutment 1 or abutment 2, but we can call this abutment 1. So it is stone masonry. And then we have our intermediate support, which is the pier. And the pier is also constructed of stone masonry with a concrete, reinforced concrete pile cap. So this is your intermediary support. And over the other side now, that's abutment 2 with stone masonry, stone wing wall, and so forth. So it's a mirror. Abutment 1 is just a mirror of abutment 2. So let me show you what is going on. So this is a two girder bridge. So this is girder number 1. This is the facial girder, right? So that bottom piece there is known as the flange. So a steel beam or a steel girder is made up of two components. It is made up of the flange and the web, right? The width of the flange is to deal with the bending moments that is going to impact the bridge due to the impending load, and the depth of the web is to deal with the amount of shear force that is going to be impacted by the bridge. So let me repeat that. So the flange is to deal with the bending moments or the moments, and the depth of the web is to deal with the shear. So let me move on, and those vertical members that you see along the girder, those are called stiffeners. So let me look up underneath the bridge, beneath the bridge. So these cross members are known as braces, right? They are known as braces. So, and as you can see, we have wood plank beam that forms the deck. I'm going to go on top of the deck and explain to you some more. Right? So this is the other side of the bridge. So this is a two girder stone masonry bridge. Right? And the two girders here, girder number 1 and girder number 2, is to carry the weight or the load that the bridge is going to be impacted by. So this is your waterway, right? So another main feature of a bridge, a bridge has 3 main features. You have the deck, you have the superstructure, and your substructure. So your deck is really to accommodate the smooth transition across the bridge, and your superstructure is known as your girder or your beams, or in the case if this bridge carry a bearing, your bearing also would be a superstructure. Below the superstructure is the substructure, which is known as the abutment or the footing of the abutment. All right? So let me go on top and show you what is going on top of this rail bridge. All right? Good. So this is on top of the bridge here. If you notice, that's the rail for the train, and this member here on the bridge deck, this member here, where my foot is pointing here, this is known as steel grid. So if you notice, the top of it is corrugated to limit the friction, that you don't, if you're walking on it, you don't slide. So many of these steel grid bridge, we can find them in Pennsylvania here, where the entire deck is steel grid. Right, and that's the railway here. And if you notice here, we have sheetrock here. There's a sheetrock here to help retain some of the structural backfill beneath the bridge. And this member here, that's a wood plank. That's a steel, that's a wood plank beam. And that's looked to me like it's around, the dimension is around about 6 inches by a depth of 1 foot. So 6 inches by 12 inches. So if you notice, they are equally spaced along the deck of the bridge. So those spacing is determined by the calculation. It is not just randomly spaced like that. It has to do with structural calculation, right? So I'm going to give you a look. As I said to you before, I couldn't have passed this bridge without giving you a background knowledge of what a bridge entails, knowing that I look at these bridge plans on a daily basis, and from time to time I have designed bridges as well. Alright, so let me go down and show you what is going on again. So let me give you a recap of what I've just discussed. So this is a 2-span non-continuous stone masonry 2-girder bridge. Yes, I hope I get that right. So the reason why I said it is a non-continuous, if you look at the girder at the pier, right, you can see where the 2 beams the two girder joints right there. So there are two separate girders that spans this bridge. If it was one continuous girder that span the entire width of the bridge, then it will be a continuous span. But because it is joined by two different girders, it is a non-continuous. All right? So all the substructure units is comprised of stone masonry, the wing wall, the abutment, the center pier, and abutment 2, right? And wing wall 2. And if you observe on the abutments on the center pier, you can see there is a reinforced concrete member or reinforced concrete cap, right? And remember what I've said to you earlier, that whenever time we have a bridge that span a feature that we have water running beneath the bridge, it is mandatory that we do an hydrology and hydraulic study. It's a comprehensive study, very detailed. We have software that we use to run the program and model the 100-year, the 50-year flood to see how it is going to impact the bridge and to determine if the velocity of the water is going to be of such that is going to scour the abutment and compromise the structural integrity of the bridge. All right? So I hope you enjoyed this video. Let me know in the comment section what you think. If you want more information as it relates to this bridge, or if you want to ask me any question, I'll be more than happy to answer your question. And if I don't know, I will research it and let you know. All right? Enough respect. Big up on yourself and take it easy. All right? Talk to you again. All right. Respect.